Okay, testing. I guess this is fine. So this is going to be a quick video. I just wanted to share some capabilities of Copilot to write some very basic but useful code, probably code that you use. You've probably written this kind of code during your examinations or quick quizzes and tests and so on. So let's see how good Copilot is when it comes to writing some useful functions or utilities. So for example, if I want to say I want to read lines from a file, so all I have to do is and let's see what Copilot does. Okay, there we go. So Copilot automatically guesses that the remainder of the function name that I want is read lines from file, takes as input the file name. It also gives a nice comment, and it automatically just does what we need, which is with open file name as f, which is very nice because this kind of, for example here, this helps you avoid having to explicitly close files, and it's a very good practice to close all files you open. So this syntax is very good. And then of course in lines you read all the lines and the lines are returned. This is very straightforward, and that's one very useful utility. Okay, and Copilot automatically is trying to suggest that I should write lines to file, and actually this is what it does. And essentially it takes as input the name of the file that we want, the list containing all of the lines or strings we want to write to the file, and this is what it generates. Very straightforward, very basic function. So these housekeeping functions, so-called housekeeping functions for reading, writing files, utility functions, you can quickly write them without actually having to deal with stuff. So now now that this is done, let's try to do something like, I don't want Copilot to suggest anything right now. So suppose I want to have a function that can print the Fibonacci series. Very straightforward for Copilot. Define print Fibo. Let's see if it can continue. Oh, there we go. Here we go. G numbers n, and automatically Copilot has detected that I want to print the first 10 Fibonacci numbers, and here you go. And this essentially prints the first n Fibonacci numbers, and you know the logic. The first two Fibonacci numbers are 0 and 1, and then it prints the first n Fibonacci numbers. But here's, I think this is a small catch. If I said print the first two Fibonacci numbers, then it should actually print 0 and 1. But here it is printing the first n plus 2 Fibonacci numbers, or n Fibonacci numbers after the first two Fibonacci numbers. So actually this is an issue. So let's see if we can correct this. Let's see what we can do, or how we can change the code to make sure that it actually prints the first n Fibonacci numbers. Let's see what it can do. If n is 0, print nothing. Okay, that's good. Let's see what it does. Okay, return. Okay, that's good. Now let's see what is the next thing to do. If n is 1, print 1. Okay, that's also true. That yes, it's doing. If n is 2, print 1 and 1. Okay, and finally there we go. This takes care of the first n Fibonacci numbers. Now let's see what we did. So originally when we had the print Fibonacci numbers, the first n Fibonacci numbers, it printed the first 10 Fibonacci numbers after the first 2 Fibonacci numbers. So it printed from Fibonacci number 2 to n plus 2. Oh yeah. So now I had to make some changes. So I said if n is 0, print nothing. So that's true. If n is 1, print 1, which is actually stored in variable a. If n is 2, print 1 and 1. Actually, it should be 0 and 1, but that's fine. And it prints a and b. That's clever. And if n is greater than 2, then you just print all of these things. Now remember, if I had to write the code by myself, naturally I would probably not, I would not rely on commenting and so on and so forth. I know the logic for Fibonacci series, but Copilot isn't that very clever in figuring out what I want, but it's able to do this kind of stuff. And now you'll see that this is actually the function that prints the first n Fibonacci numbers. Now let's see if it can actually do all this without me having to write these comments. So let's see what we can do. Def print, return first n Fibonacci. Let's see. Numbers. Okay. All right. So I think Copilot has kind of learned what I wanted to do. Learned what I have already written before, the print Fibonacci numbers. So it's just mooching of the logic, except that it's now returning all Fibonacci numbers in a list. And I think this is just doing a fine job. So I guess now we no longer have an issue, which is very, very nice. Okay, so I guess this kind of takes care of, this shows one very interesting thing, that Copilot actually takes a look at the code that you've written previously, and it adapts the next code that you desire according to that previously written code. So make sure that the previously written code is not unclean. But yeah, Fibonacci numbers done. Let's see what other things would we like to do. No indices, please. Suppose we wanted, let's say, return prime numbers in a list. So first of all, let's see what it does. Define return prime numbers. And okay, this is good. Return prime numbers. So what this will do is it will return the first n prime numbers. And see, it has adapted from my previous code. It detects these edge conditions, and edge conditions, as we know, it's very important. But what is this doing? First n prime numbers. It has, if n is 2, return 2 and 3. But then, is it taking care of the rest? Is it taking care of the rest of the code? Aha! You see, it doesn't know how to generate the, it does not know how to keep on adding prime numbers. So we already know that we already know the quickest way to detect a prime number, right? So let's do something very simple. Before returning prime numbers, we have is prime. Okay, this function is supposed to return true if the number is prime, false otherwise. So if n is less than 2, return false. That's true. If n is 2, return true. That's also true. If n is greater than 2, check if it is divisible by any number less than n. Now this is wrong, because you don't need to check to n, you just need to check to square root of n. Any number up to square root of n. And can you generate the code for me? There we go. And it does the job. This automatically is able to detect a prime number. Now let's see, define return primes up to n. Yes, why not? So primes equals to question an empty bracket, then for I in range 2 comma n plus all the way up to n, which means n plus 1 is the outer bounding limit. And if is prime, primes dot append, return primes. Of course, this is a nice way to return a list of primes up to n, but it's a very inefficient way, because this means that I have to detect whether each number is a prime or not. But there is a more efficient approach for detecting primes, and we know what it is. It's called the sieve of Eratosthenes. Let's see if Copilot knows. Sieve of Eratosthenes or not. There we go. There we go. That's good. That's good. Look at this. Look at this. Look at this. It's already able to do this. So sieve of Eratosthenes. Oh, dude. What? There we go. Return a list of primes up to n. Initialize a list of numbers from 2 to n. Numbers equals to I for I in range 2 to n plus 1. Primes equals to empty. For I numbers, yes. If I is in primes, yes, then continue. Primes dot append I. Yes. Remove all multiples of I from the list of numbers. Yes, that's correct. For j in range I star star 2 to n plus 1 with increments of I, numbers dot remove j. Okay, that's also correct. And this is the sieve of Eratosthenes, and I don't even have to check whether this is correct or not. I 100% believe. Now, Copilot knows what the sieve of Eratosthenes is. So you can assume that Copilot has implementations, or Copilot is trained on several implementations of these kind of classic functions. But in a coding competition, you will be expected to code up sieve of Eratosthenes by yourself without relying on Copilot. But if you are working as a software engineer and you probably need to write the code for the sieve of Eratosthenes, and you don't have the time to deal with the internal logic and so on, Copilot can probably write it down for you within, let's say, an instant. So sieve of Eratosthenes is done. What are some other interesting functions, some other interesting utilities that you can write? So let's think about this. Oh, how about we design a class of arithmetic operations, and let's see if we can, this is a very classic exercise, right? When you're in your engineering first or second year, when you're learning coding, you probably were asked to, let's say, develop a calculator, and let's say you design a class called calculator, and then you define the functions for addition, subtraction, multiplication, and division. And then essentially you would have to create an object, you would have to test it with different values, and you would have to make sure that it is correct or not. Okay, so let's try to do this. Class calculator, and let's see, based on this, look at this. Divide to what? To numbers. There we go. Okay, so automatically Copilot knows from the class calculator, it knows that I want to create a class that's going to have functions which can add, subtract, multiply, and divide to numbers. That's good. And first of all, add to numbers. Let's see if you can just, what's this? Sorry. Okay, add to numbers. And dude, where's the logic? Sometimes Copilot just, it just gives up randomly, and we don't know why exactly it does this. But come on, at least let's say return. Yes, there we go. That's good. So there I had to actually prompt it, push it to write code, but it's fine. Define subtract, self AB, and would you like me to write the documentation for you, sir? Subtract. Dude, why are you not coding for me? What's going on? String literal is unterminated by pylon. No, I don't care. Subtract to numbers. Is Copilot actually messing up? Okay, no, it's fine. So define multiply multiplying two numbers. Okay, now it's working out perfectly fine. Define divide, divide two numbers. Now this is a problem. Divide, you have to make sure that division by 0 is not possible, right? So divide two numbers, divide two numbers, division by 0 is not allowed. And yeah, and let's see, if b equals to 0, raise value, division by 0 is not allowed. Yes, division by 0 is not allowed. Yeah, I think this is perfect. I think this is perfect. Okay, so now we want to test this class. You see, now automatically Copilot has written all of these things. Now in a real life situation, I would probably be able to finish writing this class by myself a bit faster. But you can see that Copilot can actually do these things for you. This is just an example. So let's test. Now Copilot would be helpful, I think, in writing tests. So let's see. Define. Let's see if Copilot knows what I want. Test. And does it know to test? Test. Calculator. There we go. And it has automatically created some nice tests. It has automatically created some nice tests. So it first creates an object. It tests the add method, and calculator.add 1 plus 2 is 3. Yes, 1 plus minus 2 is supposed to be minus 1. Minus 1 plus minus 2 is minus 3. Yes, minus 1 plus 2 is 1. Test the subtract method. 1 minus 2 is minus 1. 1 minus minus 2 is 3. Minus 1 minus 2 is plus 1. Minus 1 minus 2 is minus 3. Multiplication. Yep, 1 2 times 2 is 2. 1 times minus 2 is minus 2. Minus 1 times minus 2 is 2, and minus 1 times 2 is 2. Test the divide method. Assert calculator divide, and 1 divided by 2 is 0.5. 1 comma minus 2, 1 divided by minus 2 is minus 0.5. Minus 1 divided by minus 2 is 0.5, correct? And minus 1 divided by 2 equals to minus 0.5. And 1 divided by 0. You see, it cleverly even tests the divide by 0. So this means it is able to look into my previous context where I have prevented division by 0. So that's very clever, and that means it's good. So now suppose I wanted to test the calculator, but I wanted to run n tests. Okay, then let's say define test calculator later, but how do I want to pose this? No, I don't want to test calculator class. N times. Now let's see what it is able to do. It's not able to learn this properly. Okay, test calculator with random values. Okay, let's see if Copilot. Very interesting. Very interesting. Very interesting. Okay, so this test the calculator class with random values. Yes. Okay, however, I don't want, I still need to do something over here. Test the calculator class with random values. Make sure division by 0 is tested properly. Yes, and additionally what I want it to do. Oh, this is good. What else do I want this test to take care of? Return the time. Return the time it took to run the test. There we go. And return the time for each, return the time for each test. You should be able to do this for me. Come on. Ah ha 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 ha. It doesn't do it for each operation. Does it? No, it doesn't do that. Okay, return the time for each test. Come on, can you do this for me? Come on. Oh, there we go. I think this should be fine. Okay, let's see what it did. So I said import time. It says import random. That's good. Create a calculator. Test the add method. Start time equals to time.time. Yes. For I in range 1000, so it tests 1000 times. A equals to random.randint, B equals to random.randint. Assert calculator.add a b equals to a plus b. That's beautiful. End time is in time for 1000 add test. Perfect. It does that for subtraction. It does that for multiplication. And let's see what the division thing is. Okay. Test the divide method. Now it's making a mistake with the divide method because it doesn't handle division by 0. Unless calculator.divide, no, so it division by 0 is not allowed, and here, okay, there you go, perfect. See, and voila, this is exactly what we wanted. So remember, for testing by division by 0 was not allowed. Originally it did not handle this division by 0. It did not try to detect this whole how should I say, value error when division by 0 takes place. So start time, you take 1000 numbers, random, try, calculator.divide. If b is not 0, then should be fine, but if b is 0, then it should return a value error, and then it returns the end time and time for 1000 divide test. There we go, and there you go. Not only did Copilot actually basically simply help you write a simple class, but it also helped you run tests, and tests are very important, because tests help you consider all kinds of corner cases. This is a very simple example, but I think in the future I'd like to how should I say, I'd like to try more complex tests and try to test boundary conditions, run times, and so on. Now you can see, like, Copilot just, if you wanted to check the runtime for each function call or whatever, or 1000 function calls, automatically it helps you do all these calculations without you having to wonder, oh, what is that class for starting the counter, like, timer, and stopping the timer. It's all here. So with that, I think this is some of the basic code that Copilot can help you write, and especially tests. So I know we did some random things, but I'll try to structure my stuff better in the future. And with that, if you like this, please comment, like, suggest, criticize. I'm open to criticism. Again, I'm not some coding guru or anything like that. I just enjoy coding, and I have coded for quite some time. I'm not as good as any of those Google coders. I know that for a fact. But I just wanted to share this because it's all fun to me. But if you learned something, that's good. So do let me know, and I hope that I'm pretty sure I'll be churning out a few more interesting videos. At some point of time in the future, I'd like to see if Copilot can help me create some kind of a simple game or a simple app. We'll see if Copilot can help us write web pages, handle all of the Ajax calls and whatnot. Let's see. And I want to, again, and I mentioned this in my previous video, I want to see if Copilot can help me design neural networks and train neural networks, let's say for image classification or any kind of deep learning application per se. So yeah, thanks for watching my video, and once again, like, comment, subscribe, criticize, what have you, but please interact. And of course, if you like this, do share.